Nancy Yang from the University of Oxford. Science from the Signals Planetary Nebula Survey, stellar populations, planetary nebula luminosity function distances, and dark matter.
Great. My name is Nancy Yang. I'm a second-year PhD student at the University of Oxford, and I've been working on making planetary nebula catalogs using SATEL data. But since my field is fairly niche, let's start with the very basics. Planetary nebulae are formed out of asymptotic giant branch stars, so when they shed their outer layers, the inner core gets revealed, and this core is so hot it ionizes the area around it and results in very bright emission lines, mainly the O3 5007 emission line. And the image you saw on the very first slide, that was a planetary nebula in our own Milky Way. So very beautiful structures, but unfortunately at the distance of even just the Signals galaxies, which is about 4 to 10 megaparsec, they're completely unresolved, so we expect them to look like point sources. The reason people look at planetary nebula, they're related to the stellar populations that they are formed out of. So they're sensitive to changes in the mass and metallicity and age of those stellar populations. They can also be used as dynamical tracers because they're discrete point sources. They are very bright. They're easy to detect even in the outer halo of galaxies where stellar continuum itself is harder to measure. And we can get the velocities from the emission lines. Then there's also the luminosity function, which is what a lot of the recent work on planetary nebulae has been about. So you see this trend at the top right plot there. There's a very steep cutoff for brighter magnitudes. And it's been empirically shown that this cutoff is at the same absolute magnitudes for different galaxies of different Hubble types, again, different mass, different ages. And that means that if we measure the population of PN, we can fit to this magnitude cutoff. We get the apparent magnitude, and we get a distance modulus, since we already know the absolute. Historically speaking, planetary nebulae have been mostly studied in the early type galaxies because they're easy to spot because of their O3 emission. You just take a narrowband image, any small emission point source on there that's not on a continuum image, that's a PN. But for star-forming galaxies, things get more complicated because there's so many contaminants, emission lines. So that means that only recently with IFU, we've been able to start looking at these sources, at these galaxies, but we don't have a very big catalog of them yet. So recently, Muse has been working a lot on PN research, and they're very good at everything except for their field of view, right? And that's where SATEL then comes in. So when I started the project, I already knew we had the big field of view sorted, so I just had to make sure everything else was also in place. And fortunately, we have signals data of about 40 star-forming galaxies. And this is the automated detection pipeline that I've been developing. But just to give you the big overview, we start with making some 2D images out of the 3D cube that are good at highlighting emission line sources. We then perform object detection. We plot the point sources on the PPT diagram. We select for them having very bright O3, which is where typically you'd expect the AGN to lie if you're looking at like a plot for galaxies. We then check for their morphology because we know they should be unresolved, so they look like the PSF. There's some steps to do for the calibration. I won't go into too much detail because I don't have time. And then finally, I make a mock catalog of PN with actual emission line that I input. I input that into the real cube to exactly simulate the conditions under which I'm finding my real PN. And this allows us to get a good sense of where can we find them, what magnitude range can we find them in, and when can we not find them. So these are 2 preliminary catalogs of PN for 2 out of the 40 galaxies. We are pretty good at finding PN. The ones we find, we can be very certain of that they are indeed PN. Some of them are harder to find in the centers of the galaxy, but maybe we can get that sorted again later. And just to finish, there's about 1,000 more PN for me to find when I run everything on all the other galaxies in the catalog. So thank you.
Questions? Just curious, as you were going more time into your testing large amounts, grand costs, second, that as we count through use and other.
Roughly, particulars, very low metallicity. So there's actually a small offset between what we might expect if we assume a distance. Yeah, thank you.
Good, thank you very much.